All right, my friends, you have made it to slide 3, which is asking you about maxima and minima. So in this assignment, you will be given the graph of a function and be asked to determine if the graph has a maximum, a minimum, or neither. And if you're confused about the title, maxima is just the plural of maximum. So if I'm talking about more than one maximum, I would say maxima. And that comes to us from Latin, where a is a plural ending, where is a singular one. So same thing with minimum. If we're talking about more than one minimum, we would say minima. And so that's where that title comes from. But all we're looking for on this is to look at the function that we have and to determine if it has a maximum, that is an absolute highest point, or a minimum, an absolute lowest point, or if it doesn't have either of those, which is also a possibility. So, a couple things to be aware of. First of all, if you see a graph continue right to the edge of what is either on your paper or on your screen, whatever media it's being presented on, that is an implication, that is, it's trying to tell you that that graph will continue forever in that direction. So this graph will come off the end and keep going upward just like it did. Likewise, over here on this side, it's going upward and it will continue going upward forever off the screen. So on both sides of this function will continue upward forever, which means there's no highest point, because any point on that graph that I pick, there's always going to be some other point higher up, even if we can't see it on the graph that we're presented. On the other hand, if we look down here, the lowest this function ever goes is right there. And there's no place on this red line that is lower than that place right there. So we would say that this function has a minimum. And if you'll recall, this is called a quadratic function, these U-shaped functions. And quadratic functions will always have either a maximum or minimum. They can't have both, but they will have one or the other. Absolute value functions, the ones that are shaped like a V, will also always have a maximum or a minimum. So in this case, we can see that that was the correct answer. Here we have an absolute value function that again has a lowest point, that is a minimum. And in this case, we've got a linear function. It's just a straight line. And so in this case, it's going to continue going upward forever off of this side, and downward forever off of this side. So no matter what, I can never select a point on that red line where there is nothing lower or higher than it. There's always going to be a higher or lower point on either end. So linear functions will have neither a maximum nor a minimum. And it turns out that exponential functions, the ones that are shaped like a hockey stick, those do not have a maximum or a minimum either. And so we can see that was a correct answer. Here we have a quadratic, so we know it will have a maximum or a minimum, and it's got a highest point there, so we would say this is a maximum. And here is an exponential. I know it's very tempting to say this has a minimum because it looks like it's getting there, but remember, as we discussed earlier, that this will continue getting lower and lower and lower forever. So no matter what point you select on that line, there's always another point that's just a little bit lower. Likewise, because it continues off the graph here, there's always a point a little bit higher. So an exponential function has neither a maximum nor a minimum. And you will go through continuing this process until you have 15 correct. If you have questions, as always, ask your teacher. They will be more than happy to help you out.